This is our start to our unit on sequence and series. We're going to just start with sequences, and a sequence is something that you're actually familiar with. A sequence is simply a list of numbers. So a sequence is just a list of numbers. So, for example, if we have something like this, 1, and they're separated by commas because it's a list, 1, 4, 9, 16, 25, something like that. Dot, dot, dot means it continues on. Hopefully you see right away that those are our perfect squares. So you could describe it in words. You could say those are perfect squares. Perfect squares. And you could even write a rule for this. If you relate the numbers in the sequence to the term number. So this is the first term, this is the second term, this is the third term in the list, this is the fourth term in the list, this is the fifth term in the list, and you can see that if the term number is basically n, that you would take the term number and square it to get the actual number in the sequence. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So you could in fact write a you could write a rule saying that you do n squared. Okay, so if I wanted, for example, the 10th term in this sequence, I could just follow this rule. I could plug in 10 for n and say 10 squared is 100. Okay, so that's a sequence. Let me give you another example of a sequence. So here's an example that you probably heard before. 2, 4, 6, 8. Who do we appreciate? 2, 4, 6, 8. So you can see that how are you going from one term to the next? Well, you're adding 2 each time. So you can write a description, add 2 each time. You could write a rule, and we'll talk more. You don't need to do this on your homework yet, but if a term number, if that's the first term, that's the second term, that's the third, that's the fourth, what are you doing to the term number to get the actual number in the sequence? Well, you're multiplying by 2 to get the rule in this case, which again you don't need to do on your homework, but I'm just giving you a preview, is 2n. To go from the term number to the actual sequence number, you would multiply the term number by 2. 3 times 2 is 6, 4 times, if you plug in 4 in here, 2 times 4 is 8, etc. But to go from one term to the next, you're actually adding 2. So what that makes this sequence is called an arithmetic sequence. When you add a constant, it's an arithmetic sequence. This is not an arithmetic sequence. This is. So whenever you add a constant like that, so it's called arithmetic. You would describe your sequence as arithmetic. So that's a very important vocabulary word, arithmetic, if you add a constant each time. Then it's considered an arithmetic sequence. So this example here, 2, 4, 6, 8, is an arithmetic sequence because you're adding 2 each time. This example is still a sequence, and it does have a pattern. However, it would not be considered an arithmetic sequence. So this example was an arithmetic sequence. Let me give you another example of an arithmetic sequence. Right here, example. Let's say I have 3, 0, negative 3, negative 6, negative 9, ... So what are we actually adding each time to go from this term to that term, etc.? What are we adding each time? Well, if you're not sure, you can actually subtract any two consecutive terms to figure it out. So, for example, -6 minus -3 is -3. -9 minus -6 is -3. 0 minus 3 is -3. So you're actually adding -3 each time. So that is arithmetic. It is arithmetic because you're adding a constant each time. Even though it's a negative number, it's still a constant. So that's arithmetic. And then there's the other type of sequence that's called geometric. A geometric sequence. Geometric. That's your other vocab word. Geometric, and that means that you simply multiply by a constant each time. Multiply by a constant each time. That would be geometric. So let me give you one example of that, and we'll call it a day. So let's say you have 1, -5, 25, -125. Okay? You're clearly not adding a constant each time, because if from 1 to -5 you would have to add -6. Then to go from here to here you would have to add 30. So you're not adding a constant. Hopefully you can see that you're multiplying by 5, except it actually has to be -5 because the signs are changing each time. So the rule is you multiply by -5 each time. If you're and that makes it geometric. And that in your homework, that's all I need you to do, is I need you to say they'll all be sequences, okay? They'll all be numbers separated by commas. You need to tell me if it's arithmetic or geometric, and describe what's happening. And then it might be neither. It might be something like perfect squares, and then you would just describe the pattern, but you would not say it's arithmetic or geometric. One last tip. If you're not sure what you're multiplying by, let's say you're not sure, question mark, you can take any term, you can just divide consecutive terms, and you should always get the same answer. So let's try that. What do I mean by consecutive? That means next to. So I take the -5, I divide by 1. What do I get? Oh, -5. I take the 25, I divide by the number in front, consecutive terms next to, divide by -5. Oh, look, I also get -5. Good. And then I take the -125, I divide by the number in front of it. I also get -5. That has to be consistent every time. If you divide any two consecutive terms, you should always get this number that you're multiplying by. And that's called the ratio R. So it's a geometric sequence.